Hello, this is the luckiest maths teacher in the world. Today we're looking at binomial expansions. So we actually did this earlier in the year when we did algebra. That was way back in term 1, but we're going to look at it again because we're going to need it for our topic on quadratics. So when we're doing binomial expansions, we have two sets of brackets, and in them there are two terms, hence the name binomial expansions. So I'm just going to call these random terms A, B, C, and D. Now, if you recall, what we were talking about earlier in the year is what we have to do is we have to take everything in the first bracket and multiply it by everything in the second bracket. Now, the way a lot of people remember this is FOIL. So F is for first, so that is multiplying together the first term of each brackets. And then O means outsides, so the things that are on the outside of the binomial expansion. So here A and D are on the outside. I stands for insides, so the two things that are on the inside of the expansion, and L is lasts, where you multiply together the last thing in each bracket. So I'll do that one in blue so you can see. So that's B times D. So if I wanted to expand these two brackets, I do first, which is A times C. Outsides is this line here, A to D, so it's just plus because they're both positive, AD. Then insides I have BC. And then last is B times D. Okay, now in this particular example there are no like terms, but you need to be on the lookout because often there will be like terms. Another way you can do it is you can take each thing in the first bracket individually and multiply it by the second bracket. So what I mean by that is I could take A from the first bracket and multiply it by C plus D, and then I could take B and multiply it by C plus D. Now what you have to be careful of is that this sign here, whether it's positive or negative, belongs to the B. So it goes with the B. In this case it's positive. So then this is just the normal distributive law that we did earlier in the year. We're just doing it twice. So A times C is AC, A times D is AD, and what you'll see is that you get the exact same answer. However you do it is fine by me, I don't care. So let's look at an example. So let's say I have x plus 3 times by, say, x plus 4. However you do it is fine by me, so I'll show you FOIL. So first, outsides, insides, and then lasts. Okay, so make sure you're multiplying them. 3 times 4 is 12, not 7. These two in the middle turn out to be like terms, so I need to collect like terms. 4x plus 3x is just 7x, okay? And now we're done. None of these are like terms, okay? Fantastic. So I'll do another example, and this time I'll use the second method. So let's say I have 2x minus 1 times by 4x plus 1. Okay, so I'm going to use the second method. I'm going to take the first thing out of the brackets, like this. And then the second thing, I need to take the minus 1. I need to take the minus sign with the 1. And I just go ahead and expand them individually. So 2x times 4x gives me 8x squared, plus 2x times 1, minus 4x minus 1. Again, I have like terms, so I need to collect them. So the final answer for this is 8x squared. So 2x minus 4x is negative 2x minus 1. Okay, fantastic, easy as. So I'm going to show you some special products now. So copy these examples down if you want them. So the first thing I'm going to show you is a perfect square. So of course a perfect square just means something multiplied by itself. So let's say I have a plus b squared, which is of course the same as the thing multiplied by itself, okay? Now, if I square that and I follow FOIL, I get a squared first, and then I do a b plus ba plus b squared. Okay, now I end up with a squared plus 2ab plus b squared. So that's exactly what you would have got using FOIL. But I can use this result to make things quicker. What I've done is I've taken the first and squared it. I've taken the last term and squared it, and then in the middle is twice the product of the two things in the brackets, okay? Make sure you remember that. So let's say I have x plus 3 squared. Instead of using FOIL, I'm going to do it quicker. So perfect square, square the first, square the last, so plus 3 squared is positive 9, and I need to make sure there's something in the middle. So I go 3 times x, so the product of these two things, which is 3x, times by 2 is positive 6x. Let's have x minus 1 squared. I square the first. I square the second term. Now minus 1 squared is still positive 1, and what goes in the brackets is minus 1 times x, negative x, and then I double it. So I get minus 2x. Like that, okay? I could have got this answer using FOIL or the other method I showed you. It's just quicker this way. The other one I want to show you we also covered at the start of the year, and that is the difference of two squares. So when we're talking maths, difference just means subtracted. So if I say have a plus b and I multiply it by a minus b, if I use FOIL, I get a squared. So that's first, and then I follow the whole process. That a times negative b becomes minus ab, but this b multiplied by a here is positive, and then of course I have b minus times minus b is minus b squared, but because there's one positive and one negative, these two cancel out. So I'm just left with a squared minus b squared. That's why it's called the difference of two squares. One square, another square, and their difference. So again, I got this answer using FOIL, but I can use this result to be quicker. So let's say I have x minus 1 times x plus 1. So you can only use this when you have the same things in each bracket, but one of them has a minus sign and one has a plus sign. So in this, all you do, square the first, square the second, minus 1 times by 1. So we have a square and a square, and then look at our answer over here. We had a negative in the middle, so we just stick a minus sign in between them. All right, let's do another example. So let's say I have 2x plus 5 times 2x minus 5. Okay, so the first thing in the brackets is 2x, so I square 2x. I square 5 and stick a minus in between them. And of course that equals 4x squared minus 25. One more example I'll do. So let's say I have, 4 minus 3x and 4 plus 3x. So again, I've got the same two terms in each bracket, 4 and 3x. One of them has a plus sign, one of them has a minus sign. So to expand it, I just use the difference of two squares. 4 squared is 16. 3x squared gives me 9x squared, and I stick a negative in front of them. I could have got this answer using FOIL. I just did it a quicker way. All right, hope you've enjoyed the video. This has been the luckiest maths teacher in the world. Have a great day.